Hey there, Algebra 1. These are our notes on writing numbers as simplified radicals. First of all, we have to understand the terminology of the new symbols we're using. So the check mark or the check mark looking symbol, that's actually what's called a radical. It means we're going to be taking a number to a certain root. The number inside that we're going to be referring to is what's called a radicand. And the root we take it to is called the index. For this whole assignment, we'll be working with only the square root. In other words, an index of 2. The 2 is usually not written for square roots, but for any other root other than 2, the number will be there in the index, like a 3 for a cube root, a 4 for a fourth root, etc. Excuse me. What we're worrying about today, though, are perfect squares and square roots. So let's talk about the perfect squares. The perfect squares are the whole numbers times themselves. We're going to go ahead and list the first 12. For example, 1 squared, 1 times 1 is 1. 2 squared is 4. 3 squared is 9. 4 squared, there we go, is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 squared is 81. 10 squared is 100. 11 squared is 121. 12 squared is 144, and then we keep going multiplying numbers times themselves. We're going to use this idea to work backwards. For example, number 1, the square root of 81. What number times itself gives you 81? That would be 9 times 9. So 9 is your square root. What's the square root of 484? I notice that 484 isn't on my list, so for this one I'd probably use a calculator. On your calculator, to get the square root symbol, you press Control, then you press the x squared button, and now you have the radical symbol. You can type in anything you want. In this case, 484, and I get 22. Square root of 64, what number times itself is 64? That would be 8. So the first 3 here are just perfect squares. Easy enough. You can actually use squares also as parts of an equation. For example, I can say 18 times the square root of 4, which means 18 times the square root of 4, which is 2. 18 times 2 is 36. I can say 3 times the square root of 256. That means 3 times, I don't know what the square root of 256 is off the top of my head, so I use my calculator. Square root of 256 is 16. So 16 times 3 is going to give me 48. And I can say negative 5 times the square root of 121. That means negative 5 times 11. Negative 5 times 11 is negative 55. So square roots can actually be used as pieces of an equation or an expression to do some problem solving. Our next 3 examples are perfect squares in fraction form. If they give it to you in fraction form, I want your answer in fraction form. The trick is you square root the numerator, and then you square root the denominator, and then rewrite your fraction. The square root of 1 on top is 1. The square root of 16 on the bottom is 4. So 1/4 is my answer. For number 8, the square root of 9 over the square root of 100. The square root of 9 is 3. The square root of 100 is 10. So 3/10. For number 9, the square root of 25 on top is 5. The square root of 49 on the bottom is 7. And you can actually do these on your calculator. For example, the square root of 1/16, I can actually use the fraction option for square roots, and look, 1/4. So I can even do the square roots on here, no big deal. Now, what happens when we have non-perfect square roots? Here's where you have to use that table on the very top. So what you want to ask yourself is, for number 10, since 24 is not a perfect square, what perfect square times another number will equal 24? So if I go to my list on top, the biggest number that goes into 24 out of this list would be 4. So the square root of 4 times the square root of 6, because 6 times 4 is 24. The square root of 4 is 2. The square root of 6 is just the square root of 6 because it's not a perfect square. So I get 2 square roots of 6. I can verify this very easily with my calculator. The square root of 24, according to my calculator, is 4.89. So I'll go ahead and approximate that right here, 4.89. When I do 2 square roots of 6, like my final answer says, 2 square roots of 6, I get 4.89 also, so it checks out. That's how you're going to check your work with your calculator. So let's do number 11, the square root of 48. Square root of 48 as a decimal is approximately 6.92. Now I'm going to rewrite it as a simplified radical. So I need to find the biggest number from my list above that goes into 48. So when I look at this list, what's the biggest number there that goes into 48? And the biggest number this time is going to be 16. What I mean by goes into, that means if I divide, let's say 48 by, let's say a perfect square like 25, I shouldn't get a fraction or decimal answer. Here I get a fraction answer. But if I do 48 divided by 16, I get a whole number answer of 3. So I can say 16 is my perfect square. 16 times 3. The square root of 16 is 4. The square root of 3 is just the square root of 3. I can verify that. 4 times the square root of 3 is 6.92. It's exactly what I wanted. Now let's move on to number 72. What's the biggest number from my list up here that goes into 72? That would be 36 times 2. 36 times 2. The square root of 36 is 6. 6 square roots of 2. I can verify this. The square root of 72, according to my calculator, is 8.48. I got 6 square roots of 2, which should actually give me the same decimal, and it does. So I know my answer is correct. I'll finish up these last 3. For 63, the biggest perfect square that goes into 63 is 9. 9 times 7 to be precise. The square root of 9 is 3. So 3 square roots of 7. So I want to check, does the square root of 63 equal 3 square roots of 7? I can say, does the square root of 63 equal 3 square roots of 7? I can actually type it in as an equation right now. 1 second. There we go. 3 square roots of 7. And it'll tell me true, so I know it's right. For 90, the square root of 9 times the square root of 10, because 9 times 10 is 90. The square root of 9 is 3. So I have 3 square roots of 10. 3 square roots of 10 should be the same thing as the square root of 90. 3 square roots of 10 should be the same thing as the square root of 90. Whoops. 3 square roots of 10. So let's see what I have here. That might have gone wrong. 3, 10. It looks right to me. Let's check it out another way. Square root of 90 is that. 3 square roots of 10 is also that. So I'm not sure why in that case it didn't tell me it was true. When we see here that it is. Interesting. So maybe I won't rely too much on the calculator. I'll just use decimal forms mostly. So I'll do that for this last one. The square root of 175 is 13.2288. The biggest perfect square that goes into 175 is 25. 25 times 7 is 175. The square root of 25 is 5. So 5 square roots of 7, the square root of 7 can be broken down, should equal my answer as well. Let's try that. 5 square roots of 7. Bam, so it works that way. So that's the basic idea. For your assignment today, you're going to do numbers 1 through 6 on the top. You're going to skip numbers 7 through 12. And then you'll do 13 through 24 on the bottom, skipping the last 6 as well here. All right, that's your assignment for today. Best of luck, Algebra 1.